Alright, let's look at example 6, where we're going to solve the initial value problem. Y double prime plus y equals 0. It's initial value, so we have y of pi over 3 equals 0 and y prime of pi over 3 equals 2. So let's go ahead and substitute in our auxiliary equation. So we get m squared plus 1 equals 0. We're going to solve for m minus 1. Take the square root of that, so plus or minus I. And so our alpha is equal to 0 and our beta is equal to 1. So we can go ahead and set up our general solution. General solution, where we substitute in our alpha and our beta. Simplify. And we get y equals c sub 1 cosine of x plus c sub 2 sine of x. Now, we're going to go ahead and solve the initial value problem. We're going to plug in for our y, pi over 3. We do that, we get c sub 1 cosine pi over 3 plus c sub 2 sine pi over 3 equals 0. Cosine of pi over 3 is 1/2. Sine of pi over 3 is radical 3 over 2. Now, let's go ahead and plug into our derivative. We're going to go ahead and take our solution. We're going to take the derivative of that. We get y prime equals negative c sub 1 sine of x plus c sub 2 cosine of x. Now, we're going to substitute in pi over 3 for our x values. When we do that, we're going to set that equal to 2. So we get negative c sub 1 sine of pi over 3 plus c sub 2 cosine pi over 3 equals 2. Now, when we do sine of pi over 3, we get radical 3 over 2. When we do cosine of pi over 3, we get 1/2. Set that equal to 0. So now we have two equations, and what we're going to do is we're going to solve for c sub 1 or c sub 2. Of course, we're going to solve for c sub 1 because in front of one of the c sub 1s we have a negative, the other one's a positive, so we only have to multiply by a value. So we're going to multiply this equation by radical 3. When we do that, what's going to happen is on the our c sub 1s are going to cancel out, and we're left with 2 equals c sub 2 of 2. When we do that, we get c sub 2 equals 1, and once we get that, we're going to plug in c sub 2 into one of our equations that we solve for. It could be the first or the second, and we're going to get that c sub 3 is equal to negative radical 3. Alright, now that we have that, what we're going to do is we're going to go ahead and substitute in our c sub 1 and our c sub 2. When we substitute in our c sub 1, c sub 2 into our y equals equation, get y is equal to negative radical 3 cosine of x plus sine of x. Alright, now, when we talk about higher order equations, it's really not going to be much different, alright? So higher orders, of the higher than degree 2. So it's a sub n times m to the n. I hate when you do m and n's together, because it's kind of hard to tell the difference between the two, m and n. Alright, but so higher order equations, we're going to do the exact same. If they're all distinct roots, alright, and they're real, we can just go ahead and plug it in. C sub 1 times e to the m sub 1 of x plus c sub 2 times e to the m sub 2 of x, all the way up till we finish all of our distinct real roots. Alright, if it's, we have the multiplicity, if they are repeated, then we continue just like we did the previous time. I kind of talked about that when we went over page 2. When you have repeats, you keep going x squared all the way up to x to the k minus 1, which how many, if it's repeated 5 times, then your highest x to the power is going to be x to the 4th. And the general solutions must contain the linear combination. So again, we're just adding all that together. And then case 3 is if we have coefficients of real complex roots appear to be conjugate pairs. So say we have, y equals alpha plus or minus beta I, but then we have that twice. So m equals alpha plus or minus beta I, and then m sub 2 is equal to alpha plus or minus beta I. You're going to continue the same thing that you did with case 2. When you repeat the same exact one, you're going to put an x in front of it. And if it happens again, you'll put an x squared in front of it. You'll have an example of that in your homework. Alright, so example 7. this is a linear differential equation of the third degree because it's y triple prime. And so, to find the roots, for example, 7, we go back to a concept that you learned in, I guess, math analysis. I don't think you touched on algebra. You might have, because I don't know exactly how far or how hard y'all go in algebra 2 in ninth grade. But to find all of your possible zeros, you do your P's and Q's, where all your P values are going to be, the factors of that last coefficient or that last constant. In this case, numbers that go into negative 12 will be our P's. So that's a lot. And then Q, for this, it's always going to be plus or minus 1 because we're talking about where our, I guess it's not always in this case, but where, that leading coefficient is going to be 1. So plus or minus 1. All right. So this could really stink if you guess wrong and you keep going between all these and saying, okay, let's try a negative 12. Let's try a positive 4. And you keep missing it and you don't get it. So I would say, hey, let's try negative 3 first. Why? Because I know it's going to work. So I plug in negative 3. All right, when I plug in negative 3, I'm going to use synthetic division, where 1 is, m cubed, 3 is the 3m squared, minus 4 is minus 4m, negative 12 is that minus 12. So there's synthetic division. And what synthetic division is, I take negative 3, and this is in case you don't want to do long division. And you line up your auxiliary equation at the top, and you're going to say negative 3 goes into that. So you always bring the first value down, and then you're going to multiply negative 3 times 1, you get negative 3. Add 3 plus negative 3, you get 0. Multiply negative 3 times 0 again, you're going to get 0. Add negative 4 and 0, you're going to get negative 4. Multiply negative 3 times negative 4, you're going to get positive 12. If you get 0, you found a root. Alright, and so because negative 3 gives us 0, we have a root, so that we can say that, okay, m is equal to negative 3. Now, what's left down here is going to make up, the rest of your equation. So we're going to have m squared plus 0m minus 4, so that equals 0, and then we can go ahead and try to factor or simplify m squared minus 4 equals 0, and we find our other two roots. M is going to be plus or minus 2, so therefore m is equal to negative 3, positive 2, and negative 2. So now we put that into our general solution. C sub 1 e to the negative 3x plus c sub 2 e to the negative 2x plus c sub 3 e to the 2x. And we solved our linear third order differential equation.